Before we dive into percent composition, I'll let you pause the video here and fill in item F in your notes, which is over common names of some chemicals. First four of these are acids: hydrochloric acid, nitric acid, sulfuric acid, acetic acid, and you should be fairly familiar with those. We'll be using them from time to time. And then the other three there, ammonia, baking soda, and chalk, those are pretty common names for some chemicals that you use from time to time. As far as the IUPAC names go, azane is probably the one that's the outlier here. I don't know of anybody that's ever referred to it as azane. Everybody just calls it an ammonia gas. And be aware that ammonia is NH3. Ammonium is a polyatomic ion with an extra hydrogen atom on it, and it's NH4 with a positive charge. Bleach, lye, caustic soda, sand, and quartz are just on here as a couple of extra little common names for you to be familiar with. So you can pause that, fill it in, and then you can restart this, and we're going to talk about percent composition by mass. So when you calculate percent composition by mass, essentially what you're just doing is you're taking the mass of an element in a compound and dividing it by the total compound's mass. And you get a percentage out of that. It's pretty straightforward. I think the best way to teach that is to kind of jump into it and take a look at some examples. In the first example, I'm giving you actual mass data. So we've done some kind of experiment and determined that there's 28 grams of iron and 8 grams of oxygen in this particular compound. So we need to know what the total mass of the compound was before, and that's, of course, adding up the individual masses for a total of 36 grams. So 28 plus 8, 36 grams. So what's the percentage of iron? Well, it's 28 out of 36. And you multiply that percentage by 100 and round off to the nearest percentage, and you got 78% iron. Oxygen, there's two ways to do this. You could take 100 minus 78, or you could take the 8 divided by the 36. It's the part divided by the whole, so 8 divided by 36, multiply by 100, round off to the nearest percent, you get 22%. So that's one way to approach these problems. Another typical way to approach the problems is you don't know what the mass of your compound is, you just know what the compound is. So in this example, if I asked you to find the percent composition of Cu2S, which is copper 1 sulfide, we don't have a mass of that, so we need to determine what the mass of that is. And so you find the molar mass of that, and so you're going to add up the 2 copper atoms, and you're going to add up the sulfur atom. And when you do that from the periodic table, you're going to add it up and get 159.16 on that. So to find the percent copper in that is you can take all the copper. So the mass of copper from the periodic table, as I looked that up, that's about 165.5. And so there's 2 of them, so you multiply that by 2. And I got 127.1 when you actually use all the numbers. And we just found out that the molar mass is 159, so that's the whole part. So this is both copper atoms added up, divided by that, multiply by 100, and I'm going to take that out to several different decimal places. I recommend you take it out to at least 1. And I got about 79.85%. You do the same thing with the sulfur. You've got 1 sulfur atom. The mass of sulfur off the periodic table is 32.07. Divided by the whole thing, multiply by 100, and you're going to get about 20.15% or so. So that is percent composition by mass. We're going to take a look at your homework packets on page 6. So if you haven't gotten those, pause the video, get that out, and look at page 6 of that. So in taking a look at page 6 here, I'll bring this over into the view. Got a series of problems here on the first page. Got 5 of them for you. And the first 2 of them, I give you the formulas. So we have ammonium sulfite, and you're going to find the percentage of nitrogen and hydrogen and sulfur and oxygen. And I recommend off to the side here, you do your little work and show me your actual divisions, just like I did here on copper and sulfur on the sample problems. Over here, right below the formula, you should write the molar mass, because you're going to be using the molar mass in all 4 of these. The next one we have aluminum acetate, and so you're going to tell me aluminum, carbon, hydrogen, oxygen. Now after the second one, now I get a little bit tricky. In 3, 4, and 5, I tell you the names. I don't tell you the formulas. So you got to get the formulas right. So sodium bromide, you got to write the formula for sodium bromide correctly. Copper 2 hydroxide, same. Magnesium carbonate, same. So what you'll do is you're going to work these 5 problems. Be ready to talk about these on Monday. And then if we're okay, we'll continue on and work page 7, which is on the other side. In the meantime, on Tuesday, we're probably going to have a little lab experiment and do a simple determination of percent composition, and then we might have a more difficult one later. All right, have a good weekend, and I will talk to you later.